In previous videos, we've covered components, specification, and reasoning. In this video, we're going to try to look into the future. Specifically, we'll talk about formal reasoning and see what challenges lie ahead for it, if it's ever going to be accepted by mainstream software developers. Now, what in the world is this? Well, this happens to be one of the most significant applications in the history of computer science. And if you think it looks like an early spreadsheet program, well, you're right. Now, I'm not going to ask you to pause the video for this, but you get a gold star if you can give me the name of this program and tell me why it is so significant in the history of computing. 10 seconds to think about it, starting now. Okay, this program was called VisiCalc. It was one of the earliest, if not the earliest, spreadsheet programs. Now, until VisiCalc came out, the only people who had personal computers were hobbyists. When VisiCalc came out, ordinary people began to see the benefit of having a personal computer. And people began buying personal computers just so they could use VisiCalc. That's why VisiCalc became known as the first killer app, an application that is so desired that people will change the way they do things in order to use it. In the case of VisiCalc, it compelled people to buy computers that they otherwise thought they did not need. But what does this have to do with formal verification? Well, a lot of folks in the formal methods community think there needs to be a killer app for verification in order to get software developers to take verification seriously. And the funny thing is, most people think they know what that killer app will be. In 2003, Tony Hoare, Turing Award winner, language designer, formal methods proponent, and inventor of Quicksort, issued a grand challenge to computer researchers to construct a verifying compiler, a compiler that guarantees the correctness of a program without even running it. Here are a few other grand challenges that Hoare felt a verifying compiler would be comparable to. As you can see, some of them have been achieved and others have not. So, what's the big deal, and what would a verifying compiler look like? Well, not everyone is going to answer that question the same way, but I'm going to give you one possible answer. The verifying compiler in this diagram consists of 4 components: an editor, a compiler, a verifier, and a library. The flow through the system looks like this. In the editor, developers not only write code, but they write formal specifications as well. Once both the specifications and the code have been type checked, they're sent to a verifier. The verifier generates verification conditions, similar to the obligations we created in the reasoning table. And it sends them to a prover to try to prove them. If the prover can discharge all the verification conditions, the software is verified as correct with respect to its specification. There are 2 main challenges for a verifying compiler. First, developers would need to write both code and formal specifications, and they'd need a good reason to do this extra work. One possible motivation could come if the verification could significantly reduce the need for component testing. Developers spend a significant portion of the lifecycle testing their code. If writing specs reduced the time they had to spend writing tests, That would go a long way to the adoption of a verifying compiler. The other challenge is that we don't yet know the extent to which the prover can be automated. Generating verification conditions is relatively easy for a verifier. Proving arbitrary mathematical assertions is not. That is something that's difficult. If you want to get an idea of what a verifying compiler might one day look like, I suggest taking a look at the Daphne tutorial at the Rise for Fun website. If you go through the first 5 sections, you'll get an idea of how to combine code with specification and how the verifying compiler can help you ensure that your code does what you want it to do. The other papers are various references that discuss specification and reasoning. And that's it for this series of videos on how to reason formally about your code. I hope you found it interesting, and I'll see you in the next module.